Hi everyone, my name is Mooneer Salem K6AQ, and today I'd like to talk to you about miniaturizing digital voice using the ESP32 microcontroller. So a little bit about myself. I've been licensed since the early 2000s. My original call sign was KG6AOB. And during the day, I'm a software developer at a medical device company where we primarily work in C and C++. A little bit of C# and Python thrown into the mix. And in my spare time, I do a lot of open source development. My biggest project that I work on currently is called FreeDV. What exactly is digital voice anyway? Well, in short, it's a method of modulating a digitized voice signal for transmission. And that consists of a few steps. First step is typically that your analog voice is fed into your computer or microcontroller via some sort of analog and digital converter. If it's your computer, that's typically your sound card. Next up, software on your computer or microcontroller modulates that digital audio into a form that can go back out over the air. And initially, that doesn't seem like it makes sense. You're digitizing something. But in reality, our radios typically deal in the analog space. So we have to put it back out into a form that our radios can understand and know how to deal with. And so once that's done, it goes out over the air. And the receiver, on the other hand, basically does these steps in reverse order. So the digitized signal from over the air gets converted in by an analog digital converter. Software on your computer demodulates and back into analog audio, and then that analog audio is played back. So on the normal PC, digital voice is typically done through some sort of software application. And one of these software applications is called FreeDV. And FreeDV is basically a digital voice program or digital voice modes that are optimized for HF use. And there's a wide variety of different modes depending on the current HF band conditions. And that's all well and good, but there's a few downsides to needing a PC. The biggest one being that if you're running a desktop at home, you're not necessarily going to want to carry that out on a POTO or SOTO activation, for example. And even if you take like a laptop, for example, you still have to figure out how to power that somehow if it's more than a couple hours at a time. And you still have to carry the laptop around as well. So I was thinking of a way to miniaturize the FreeDV onto some sort of microcontroller. And the first one that came to my mind was the ESP32. Why the ESP32, you might ask? Well, one big thing going forward is that it's pretty inexpensive. It's about $4 to $7 each in pretty small quantities. And because it's so inexpensive, a large developer and maker community has sprung up around the ESP32, which is good because if I ever would want to run into any problems, I could Google the problem, and most likely someone else has already run into it and has the solution for it. Whereas some of the less common devices out there, your support may very well only be the vendor who makes it. So then you have to deal with the vendor, and in addition, that stuff usually costs a lot more money too. The ESP32 also has built-in wireless support, both Wi-Fi, which is nice for communicating with the newer radios out there, for example, the 705 or IC705 rather. And depending on the particular ESP32 part, some of them actually have Bluetooth support as well. So you could potentially communicate with wireless headsets. So it turns out there's already a project that miniaturizes FreeDV, and it's called the SM1000. And what the SM1000 basically is, it's a handheld microphone that has an RJ45 connector and power. And you wire up the RJ45 into whatever radio you're going to be using it with. And the power is just simple 12-volt DC. And it's actually a really nice device. Like the only problems is that you can't really get it right now. It's out of stock due to the chip shortage has been going around, and there's no ETA on when that's going back into stock. It's also pretty expensive. It was around $200 US before it ran out. So that's a pretty big hurdle for some people who would want to dabble with digital voice. And then the fact that there's an RJ45 and you have to make your own cable for it, add some complexity to the setup. So I figured I'd try the ESP32, some sort of ESP32 device, and make sure that I can actually get FreeDV to work on it. And the easiest way to go about this was to buy an already created dev board. So I was looking around online and I found what's called the Nano ESP32 S3 from Tindy. Now this was before I realized that expansive, who makes the ESP32, also has their own, I guess what effectively an evaluation board. But at the time it was pretty cheap and easily accessible, so I went ahead and bought the version on Tindy. And at the time I made sure to get the model that had extra RAM, 8 megabytes to be exact. And expansive calls this the N8R8 variant. And it turns out that this was a good idea, and I'll go into that later. And then, so I waited, and then I eventually got the Nano ESP32, and I decided to start working on the code. And while I was working on the code, I found that there were some ARM-specific things in the code base. And of course, this makes sense because the first embedded device that FreeDV was made to work with was the SM1000, which itself uses an STM32F4. But the fortunate thing was that the only ARM-specific things in the code base seem to point to the CMSIS library. And what this is it's a library developed by ARM themselves that effectively has a bunch of DSP functions. And it turns out that expansive has their own version of that called ESP-DSP. And of course, it's not exactly a port of CMSIS, it's their own reimplementation of similar functionality. But the code, how you call the functions is close enough that it's almost a drop-in replacement. So I went ahead and I updated the code base to effectively implement a wrapper of some sort. And this is a publicly documented wrapper. It's currently a couple functions in it, one for real value dot product and the other one's for complex value dot product. And what this does is it effectively allows whoever is putting FreeDV on an embedded microcontroller to just implement those two functions in whatever way they'd like, and they're able to use FreeDV effectively. So now that I got FreeDV to actually compile, I had to figure out how to get sound into the ESP32 itself. Now the good news is that the ESP32 does at least have an analog to digital converter. And some models have a digital analog converter as well. Unfortunately, the ESP32 S3 only has the ADC. So at best, I would only be able to get audio into it and not out of it. In addition, the ADC in the ESP32 S3 is only about 12-bit, which very well could work, but I decided I wanted an all-in-one solution. So was researching some more, and it turns out that there are various chips out there that basically implement audio input and audio output. And one of them that's pretty commonly used is the Texas Instruments TLV320. And it seemed reasonably priced, had the functionality that I needed, which honestly wasn't that much. And the TLV320 is also already used in some ham radio devices. For example, the Yellowcraft KX3, if you've ever downloaded the schematic, it actually has a TLV320 in the schematic. So just like with the ESP32 itself, I wanted to get some sort of evaluation board to figure out if the TLV320 would even work for this application. So I looked on Texas Instruments and various other places, and the TLV320 EVM, which is what they call the evaluation board, is $300. And I thought this was insane for what's effectively a $10 per and low quantity part. So I wasn't necessarily going to spend $300 on something that I wasn't fully sure was going to work properly. So I was thinking, why not just build my own evaluation board? If nothing else, I'd get a little bit more electronics knowledge and experience, and it'd be something to do in my spare time. In addition, SMD assembly is actually pretty reasonably priced now. JLC PCB, for example, only charges the part cost and a fee for every part to consider is extended. I'm not sure what that means, but it seems like a lot of the parts are extended for what it's worth. So I went in KiCad and did a schematic and did an initial PCB design, and that resulted in the 0.1 board, which you see on the left-hand side. And personally, I think it turned out pretty well. Of course, I did find some issues immediately after I submitted the Gerber files to JLC PCB, which of course is how that always works. And I still needed to develop the firmware for this, which ended up immediately going into what I call I2S hell. And I call it that because I wanted to run the TLV320 at an 8 kilohertz sample rate, which turns out isn't exactly too common. A lot of the quick start code that I was seeing online was assuming 48 kilohertz or 44.1 kilohertz. And if I went with one of those, I would effectively have to up convert and down convert in the code, which is what I was trying to avoid. So I ended up spending a lot of time with the Texas Instruments documentation and some of the helper tools they provided to come up with the right constants to and I2C code to pass in. And even with all that, it still took me days of debugging on the firmware side to get something that was usable. And eventually I did come up with something that was usable. But I found that one of the channels, which was the audio in from the headset, wasn't really working. When I tried to loop back at the firmware level, I only heard noise on there, like pulsing type noise. And when I probed with my oscilloscope, it looked suspiciously like 60 hertz pulses, which was kind of weird because the board itself only ran on DC. So at the time, I was thinking maybe it was picking up noise from something else that was not properly functioning at my house. In addition, I was thinking that software bugs wouldn't cause only a quarter of the available audio channels to not work. Like if it was a software issue or how I was configuring the TLV320, everything wouldn't work. Or that's what I thought anyway. So after banging my head for a little bit, I decided to just bite the bullet and respin the board. And the goal of respinning the board was to try to mitigate what I assumed was an EMI problem and fix the issues that I talked about, like finding right after I submitted the 0.1 board. And that resulted in the board on the left. What I effectively did was I added a few mounting holes to make mounting in an enclosure easier. And in addition, I basically rerouted all of the traces to and from the TLV320 to make them as short as I possibly could in case noise was getting picked up on the traces. I also added a lot more vias, especially around the signal traces. And the reason why I wanted to add them around the signal traces was I wanted to try to create a Faraday cage of sorts. So if there was a noise issue, that would reject a lot of the noise, or as much as I possibly could. And then I just did some general component tuning, especially around the LEDs and the buttons. And then after doing all this, even though I got a really nice board out of the whole deal, the noise was still there. And that freaked me out initially because I thought I made the same exact mistake that I made with the 0.1 board. So decided to research and investigate some more. And then I discovered that the TLV320 had loopback modes built into the chip itself. And those loopback modes effectively bypassed the microcontroller. So I started testing with those modes. And I found that all the channels worked fine. Audio input on both the radio and the headset side, as well as audio output for both. So it was a firmware issue after all. So after I realized it was a firmware issue, I was able to find the bug pretty quickly. And it turned out it was a memory buffer issue. And once I fixed that, I basically had a working device. And this device now effectively had support for the same FreeDV modes as the SM1000. And those modes being the 700D, 700E, and 1600. In addition, the board had CW-based feedback when switching modes, similar to the SM1000. as well as volume controlled via the push buttons for both receive and transmit. And the nice thing is that because the ESP32 has a significant amount of flash on it, I was able to persist those settings to flash. So I would only need to configure the audio settings once, and I would basically always have them, as long as I didn't switch to radios, that is. So now that I had something working on the software side and the hardware side, I decided to develop an enclosure for it. And I figured it was a good time to get back into 3D printing. Fun fact, I actually tried to get into 3D printing about 5+ years ago. I backed a project on Kickstarter called the Micro 3D, and I actually did get the printer, but I had so many issues with it that it kind of scared me off of 3D printing for quite a while. But the good news is that 3D printing is actually significantly easier now compared to that 5+ years ago. Of course, 3D printing is still not completely plug and play, but I've had a lot fewer problems with this printer compared to the Micro 3D. And the best part of it is much less expensive than it was back then too. For instance, I got my Ender 2 Pro for $130 at Micro Center, which I think is a pretty good deal, honestly. So after I bought the printer, I started investigating how to do 3D modeling. And I was reading about some of the programs that were out there, and I ultimately decided to go with OpenSCAD since I liked how you could just effectively write code and you get a model. So that might not be the most common choice, but I found that choice worked best for me since I was mainly going to be using it to make enclosures and such. Even then, since this was effectively my first time doing 3D modeling, I still needed to print the enclosure a lot of times to get it at least somewhat right. And a lot of that was because, like, you would think that just creating a box would be simple, but I wanted a box that had buttons and built in that would stay with the enclosure without falling out while I was trying to assemble it. And because of that, every print would have at least something wrong. Like there were times where the buttons were stuck or I couldn't get them unstuck from the rest of the enclosure, or buttons that just broke entirely while I was doing that. And then finally, I was able to get the enclosure you see on the left. So in this enclosure, the buttons do reliably click when you push them. You still have to take a fair bit of care when assembling it, however, but it's not impossibly difficult to assemble it like it was with the initial models of this. In addition, like I had nice, easily visible status LEDs on the right-hand side. So I thought that was pretty nice as well. So after all that, what lessons did I learn exactly? Well, hardware is more difficult and has a lot more moving parts than just pure software. A lot of the decisions you make at the hardware level, like PCB, enclosure, basically feed back into the rest of it. So for instance, if you choose a particular GPIO to route a pin to, you're going to be using that GPIO in the software. In addition, vendors don't exactly make using their products all that easy outside of common use cases. So you're going to be reading a lot of documentation. And if you don't have much experience with a part, you're probably going to be experimenting for a bit until you find something that works. But the good news is that hardware development itself has gotten a lot more accessible. Even 5 years ago, a place like JLC PCB or PCBWay or one of the many others out there wouldn't have been possible. You wouldn't have been able to just get 5 boards made. You would have had to get a bunch more boards made for a lot more money back then. So just for one-off prototypes, it's actually much better, much easier for the hobbyist to get into. Another lesson is I needed to spend more time to definitively rule out firmware issues before actually concluding that I needed to respin the board. Now, if I had done that, it would have been possible that the 0.2 board either wouldn't have been needed or I would have been able to delay respinning for quite a while. So what are some of the next steps? First off, I wanted to use the extra RAM that's in the board that I got to flesh out the Wi-Fi functionality some more. Now, the reason for that is I had prototype code for IC705 wireless support in there. And that did work for 30 seconds before the board basically crashed. And that was because the FreeDV itself actually uses up almost all of the native RAM that's on the ESP32. So whatever's left gets used up by the IC705 support pretty quickly. When I enabled the extra RAM support on in the ESP32 firmware, the IC705 support basically didn't cause it to crash, but I found other issues, mainly around audio dropping out during transmit. So generally, the reliability of the IC705 support needs to be improved. Additionally, I'd like to add some web-based configuration for some additional features that would be nice. For instance, encoding your call sign in the audio data so that people using the FreeDV application, for example, can report you to PSK reporter effect. So that's actually a pretty nice feature. So you can see where your signal is getting out, say if you're trying to do a POTO or SOTO activation with FreeDV. Additionally, I'd like to do some code optimization. For instance, FreeDV has a software bandpass filter, which is required for 700E, but is optional for the other modes. Unfortunately, this takes about a quarter of the amount of audio that's encoded and decoded per pass, which might be doable, but we'd get pretty close to using 100% CPU if it were to be enabled. So I would like to cut that amount of time down from 40 milliseconds if possible. I'd like to also spin the board again, but have the ESP32 built onto the board instead of just headers like I had been using before. And doing so would lower the cost and the complexity. And it would also potentially decrease the size of the board, or even allow more functionality. For instance, battery power, or even having a built-in mic or speaker similar to the SM1000. I'd like to also play around more with the enclosure, like maybe printing with a different material would make it easier to assemble or potentially more reliable. Or I could redesign the buttons to improve their reliability, improve their strength as well. So the good news is that you can help with all of that. I have open sourced the source code and the schematics, and I have placed them on my GitHub, github.com/tmiw/ezDV. And I welcome pull requests on that if you see something that needs to be fixed or you'd like to add some new functionality. If you'd also would like, we also welcome work on the upstream FreeDV and Codec 2 libraries, which is what ezDV is based on. And links for those GitHub repositories are on the slide. So that's about all I have. I'm going to go ahead and open it up questions at this time.
Okay, very good. Thank you. Thank you very much, Mooneer. Really good stuff.
No worries.
We have a couple of questions. It looks like Wade VA3 NCA had a question if you had considered the Teensy 4.1, but it looks like he said never mind. No built-in.
I could still talk about the Teensy 4.1. Basically, I do have not exactly the ezDV, but like I have another. I was playing around with a dongle type of thing that plugs into the back of Flex radios to enable basically using using Smart SDR with FreeDV without having to run the FreeDV software. That's still a work in progress. So the Teensy is definitely able to run the FreeDV codec demodulation and modulation. Of course, no Wi-Fi, so it wouldn't necessarily be usable for something like ezDV without extra hardware. So in short, I have played with the Teensy 4.1, and it's actually a pretty nice device in general.
Yeah, fantastic. Okay, we have another question from Bo K6AQ. Enjoying the talk and big fan of the ESPs. Did you find any particular flavor of the TLV 320 XXX to go with minimum feature specs and such? I imagine there are other options for an I2S ADC, and this one made sense to available info and reference code as a starting point.
So it looks like Bo solved the schematic already, but I was basically I was using the AIC 3254 variant, and the main reason for that was it had a stereo, at least one stereo input channel and one stereo output channel. And in the code, I split off the left and right channels into their own like virtual channels effectively. So like in the code, I believe the left channel on both is the quote unquote user device, the headset, and the right channel is what goes into the radio. But the biggest reason why I went with the AIC 3254 was it had pretty good availability on JLC PCB's assembly service. So using that meant I didn't have to wait and for however long for JLC PCB to give me the boards after I sent them in for assembly.
Okay, very good. And I wanted to bring this one back over here too. Wade, WA3NCA, had another question, but it does have an audio hat for 16-bit audio in and out. So
I think he might have been talking about the Teensy, but
oh,
like
mm,
and I believe it does. I haven't played with that audio hat unfortunately, so I'm not fully sure the specifics of that, but that might be something to research for future use.
okay. And we have one more from Bo again, K6AQ. Thanks for the share. I see the specific chip used in the schematic, and he has a link to it down below there as well. Okay, and we have, looks like one more question here from John in N05X. Have you considered the new Zinc 7 dual core ARM FPGA development boards?
It's honestly the first time I've heard of the Zinc 7. I have played a little bit with doing FPGA stuff before, but I haven't gotten too far into it. It would be kind of cool, very, 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 very long term, to like have a FreeDV implementation that runs on an FPGA, because then you could just plop the FPGA on whatever board or whatever device you want to use. Or say like if you're a radio manufacturer, you plop the FPGA on your in your radio and you basically have FreeDV, for example. But that would have to be something, like I said, very long term, and I'd have to like get more experience with doing FPGA development, and potentially find someone who is way more knowledgeable in DSP stuff than I am. So
There's a big learning curve with some of these things. You guys are diving into this stuff very deep. So definitely some fantastic things you're doing there. Okay, let's see. I don't see any other questions. Does anyone else in the room have anything they want to ask Mooneer on this topic here today? I don't see anything else coming in yet. We'll wait just another minute or so.
I can add some updates since I recorded that presentation.
Oh, please do.
Um, like like for example, I actually did respin the board. So I don't know how well you guys can see, but basically I have the ESP32 built directly onto the board now. And it basically made the board significantly thinner in general. And I also added some battery charging circuitry onto there. So this board, for example, obviously doesn't have a battery soldered onto it, but I do have another board in the other room that does have a LiPo battery, and is charging and discharging fine on that. So that's pretty nice. I actually haven't really run into that many issues with this new board. One big issue is that the quiescent current is still pretty high, and I think that's because the TLV320 is still powered even when it's in sleep mode. So at some point I'm probably gonna have to respin the board again and add like a MOSFET or like a BJT or something to force the TLV320 to be off, while the rest of the everything else on it is off. And then I also managed to get the IC705 support a little bit more reliable. I'm still having issues, but the audio is at least pretty consistent now. I'm still running the crashes occasionally, and I'm still working through that. One of the challenges with the IC705 support is that ICOM never released specs for the Wi-Fi communication. So a lot of the work in that has been reverse engineered. So I've been building off that reverse engineered work. And obviously, reverse engineering does have limits. It takes a while to catch all possible messaging that can go over all possible error cases. So that's just something that will just have to be worked through over time. And it looks like there is more questions, so maybe we can start taking those.
Okay. Looks like we have another question here from Richard, WA3TUU. How about the RP2040?
So I actually did try the Raspberry Pi Pico. Unfortunately, it has no floating point unit. So when I tried to run the FreeDV modem on it, it actually took longer than real time to encode and decode. So unfortunately, that wasn't really going to work without porting the FreeDV stuff over to fixed point, which again, I don't have nearly enough DSP knowledge to even attempt something like that. So that would have to be something very, very, very long term if that were to be done.
Okay, I don't see any more questions. So please, anyone else, if you have anything you want to find out from Mooneer here, please drop your question in here for us.
Um, there is a share screen thing. I can try to I have the current schematic up and running if anyone is or I guess the current PCB up. So this is the 0.3 board that I just had made. So the buttons on the left-hand side have PTT, mode, volume up, and volume down. And then these two buttons are designed for resetting the ESP32 as well as putting it into DFU or flash mode. So you can flash new firmware. This component that's labeled 33 is the TLV320. And then this portion over here is basically the battery charging circuitry and the LDO to convert the 4.2 volts up to 4.2 volts for the battery, 5 volts for USB, down to 3.3. And then there's two 3.5 millimeter jacks down here. One of them, I believe it's this one, is for the headset, and the other one is, and the headset is basically wired for Android. So the tip and the first ring are the receive audio, and then the shield is PTT, or not PTT, input audio pretty much. And then for the radio, it's basically tip is the audio going into the radio. The first ring is PTT. Second ring is ground. Third ring is the audio coming from the radio. So it's a fairly easy way to wire it. And in fact, if you're using something like the KX3, you can just buy some pre-made like TRRS cables and TRRS splitters, and basically have a KX3 cable effectively without needing to do any soldering. So that's actually pretty cool. So yeah, it looks like there's another question. What is your GitHub page? So the page again, it's on the slides, but again, it's github.com / Tango Mike India Whiskey / and then the ezDV is the project.
Okay, fantastic. All right. Any other questions? I really appreciate the interaction, everyone, and thank you for all the great questions so far. So we're standing by for any more inquiries here.
So yeah, let me see if I can maybe I can do a little walkthrough on how the code is laid out.
Oh,
So
wonderful. Yes, please do.
I'll try to make the screen a little bit bigger. So basically I have a couple folders in here. One of them is for the 3D printed enclosure. And if you go into that, you basically have the dev board, which is the first two versions of the ezDV board. And user is the most recent 0.3 board. And then you see the OpenSCAD, and then I have an STL file as well. And if you're curious on what OpenSCAD looks like, it looks pretty similar to like software code, but it's not actually a programming language. So like you can't do full programming stuff, but the way you list out like where stuff gets ends up on your 3D model basically is pretty code-like. And then if you go to the firmware, basically you run the IDF script from this folder, and that basically builds the firmware. And then main is where most of the code is effectively. So it's split out in audio, which is basically the main like FreeDV codec stuff, as well as handling the audio mixer and for mixing the FreeDV audio with the beeper for the CW interaction. And then driver is basically drivers for like all the components on the board. So the TLV320, the MAX 17048 field gauge chip, and then GPIOs, buttons, etc. And then I have a folder with the HTTP server. That's another update that I did recently, is I actually do have a web-based configuration interface now. Right now it's just configuring the Wi-Fi and what IP address your IC705 is on. But in the future, I envision it to have more configuration options depending on like what extra functionality gets added. And the network is basically where all the wireless Wi-Fi HTTP and then the IC705 support, which is actually a significant amount of code right here. And just as a note, thank you very much to the WFVU project. They're the ones that did a lot of the initial reverse engineering for the IC705 and ICOM remote interface in general. So WFVU is a really nice free tool for Wi-Fi connectivity to your IC705 or other ICOM radio. Definitely recommend checking them out. You can run it on Windows, Mac, and Linux. So storage is where what controls the persistent storage to the settings. Task is basically just some like it's just wrapper around the FreeRTOS stuff, so I can do message passing between tasks effectively, and to wrap timer stuff as well. And then UI is basically like a UI controller, if you think in terms of the model view controller. And then ULP finally is some simple code that runs on the ultra low processor core, which is basically a tiny RISC-V core that only uses about 5 microamps of current. And this is cool because what this effectively gets us is is software wake up and software sleep. So there aren't really that many like external components you need to be able to just have the ESP32 just go to sleep. And so like when the main code is off, all it basically does is it listens for the mode button, and if you hold down the mode button for more than a second, then it turns on, or it makes the main processor wake up effectively. So
Okay, we have another question. Let me bring this over here. From Wade, VA3 NCA, do you have plans to support M17 or other modes?
I haven't really thought about other modes right now, but since M17 does use the same codec 2 library that FreeDV uses, it would be actually fairly straightforward to implement. There are actually I don't know where it is here right now, but I do have an ESP32 board that does M17 over Wi-Fi. Basically, it connects to one of the M17 reflectors over the internet and routes your audio to and from the reflector effectively. So, and I got that. I forget who developed it exactly, but the like it's definitely possible for sure.
Oh, that would be a very, very interesting way to go. I know there's a lot of development taking place in the M17 world as you and I and others are starting to work on some of those options as well. So
Mm-hmm.
a lot of promising things there. Okay, very good. Any other questions? Anyone have anything else?
One interesting thing that I noticed is with this latest version of the board is if I go to the Mac system report and take a look at USB, like it shows the board on there, but it only shows 500 milliamps of required current, and I have the USB-C resistors set for to do 5 volts and 3 amps. So I would have expected that to show 3000 milliamps or something like that. But that could just be like a Mac quirk. I know for the USB-C interface on there, I just do the ESP32 basically just they claim USB 2.0, but in reality, like it doesn't support the 400 megabit USB mode. It supports the USB 1.1 low speed and fast speed, I think, or full speed is what they call it. So up to 12 megabits a second. So the Mac could just be seeing the 12 megabits a second and assuming it's USB 1.1, so it displays accordingly. But I haven't had any power problems plugged in direct USB-C to this Mac Mini that I'm using right now.
Okay, and we have another question from Bo, K6AQ. Any particular sweet spot with FreeDV? You mentioned 10 meters. Are there any other relevant uses in VHF, UHF as well?
I know of at least one person actually who's using FreeDV over the QO100 satellite over in Europe. So most of the activity is on HF, but you can theoretically use it on higher bands, or actually use it on higher bands rather. Mainly if you use like an all mode radio, like something that can do sideband, because as a lot of people may know, most of the VHF and UHF radios out there are FM only.
And several of us have been doing FreeDV through the linear satellites as well. Ray and Maurice and I specifically. And one of the things we discovered is that we've been using, we had to fall back to 1600 mode because of the Doppler effect and the 1600 mode being a little bit more forgiving on the frequency. So as it drifted slightly, and we had the advantage of the pilot tone to help us really fine tune in on the station. And FreeDV works wonderful through the linear satellites. We've had a real kick with that too. So.
One nice thing that would be good, it would depend on significant optimization being done, would be to have the ezDV support 2020 mode.
Mm.
I don't, again, just like with fixed point and the other long-term improvements, I don't know if or when that would happen. The main problem with the 2020 mode is that it it relies on various optimizations on x86 and ARM to perform reasonably well, namely the AVX extensions on x86 and Neon on the ARM side. And without either of those, um, the 2020 mode basically uses a lot more processor power. And that's why a lot of older machines are unable to run 2020 mode. So it's effectively disabled on those. So it would be nice to like have it optimized to the point where 2020 can run on more modest hardware, potentially even like say like a Teensy, for example. I'm not sure it would ever be runnable on say the ESP32 or the STM32F4, which is what the SM1000 uses.
Mhm.
But it with more optimization, it could run on more beefy microcontrollers in the future.
Oh, fantastic. Okay. Any future questions or further questions, I should say? Looks like the question list is starting to slow down here a little bit. I'll give another few seconds here to see if anything comes in. It's been really, really good, Mooneer. Definitely appreciate your wonderful presentation. As there's a lot to be learned here, and many of us can't wait to see how this develops because we're eager to take advantage of it.
No worries. I'm personally having a lot of fun doing the 3D printing stuff and the just PCB design in general. But like my day, as I mentioned, my day job is pretty much all software, even though it is running on embedded devices effectively. So it is nice being on the other side of that, like more lower level hardware stuff. Um, the something else that would be nice. I still haven't decided whether I want to like try to make this a business or to try to do mass production because that adds a lot more complications as well. Um, like if I were to try to be a business and sell this, I probably would have to get this like FCC approved, for example, um, and or like whatever relevant licensing or regulatory agency is in your country. So then that could be a significant amount of effort as well. And since I don't have any formal EE training, I'm hesitant to just mass produce this board as is, or even like the next board spin. Like I would want someone with more like electrical engineering training to like double check my work and like actually make sure I'm not running into any issues that are attributed to the hardware right now, other than the high power usage when it's sleeping. But for all I know, it could be spewing a bunch of hash on HF, and I wouldn't even know. Um, or like it could be violating like the emissions emission specs that the FCC has, and I wouldn't know because I don't have the correct test hardware to be able to figure that out. Um, so like more someone with more knowledge in that space and like more experience like would be nice to help out on that as well. Um, so just something to think about for the future. Um, also, and if I were to go mass production, it would probably not be with JLC PCP. It would probably be with someone else. In fact, because JLC PCP is mainly designed, and those services are mainly designed for prototypes and low volume production. Um, for higher volume production, you're better off like I would probably be better off going to like a more local PCB maker or something, or PCB assembly house for that. Um, so I haven't even thought about like asking around on that any of that yet. So like that would that would be something I'd have to think about some more if I were to try to make this a mass produced sort of deal. But if you want to like get some boards made yourself, you can definitely download the schematic or you can clone the GitHub repository and open the schematic and the PCB inside KiCad. And there are some scripts that or plugins rather that JLC PCB links to that will export the BOM and all the stuff that's embedded in the schematic. And it gets you about 90% of the way there. You have to do some tweaks to the files it generates, but they're really minor tweaks and they explain what you have to change. But if you do that, then you can go ahead and submit the boards yourself for it to be made. And I can tell you that if you just do 5 boards made, it works out to about $35 a board ish. I forget the exact number. A lot of the charge is going to be the extended component feeds, as I was mentioning, because it is a low volume. I imagine if I were to try to have several hundred made through JLC PCB, for example, that portion of the cost could potentially be a lot lower. But if you're but again, if you're interested in like getting one of these for yourself, you can definitely send out the JLC PCB to have them made. The schematics available online, and as well as the BOM.
Okay, very, very good. I don't see any other questions coming in at this time. So I will leave it to you for any final comments, and then we'll drop this stream, Mooneer. But I certainly personally thank you very much. So I'll let you put the ribbons on this for us.
Cool. Yeah, no, I'm definitely glad you all are able to come out and take a look at this talk. And I know I had a lot of fun doing it. So and a lot of fun like working on this in general. FreeDV is actually a pretty cool project. If you haven't taken a look at that yet, definitely should give that a shot. Usage has been growing all the time, and we've been having quarterly activity days to like get more adoption as well, where everyone basically is on FreeDV on HF. Basically, it depends on like we try to schedule it so we're not like interfering with any contests or anything, but it tends to be around every 3 months or so. The next one I believe is going to be, I'd have to take a look again, but I think it's going to be like sometime in late October, early November. So I'll have to, if you're interested in hearing announcements on that, you can subscribe to the Digital Voice mailing list. That's linked on the FreeDV website, freedv.org. And with that, if there are no other questions, I guess we can go ahead and close it out.
Okay. Thank you, Mooneer, again. All the best.
No
And
worries.
thanks to everyone for attending. Appreciate it.